Hello friends, welcome back. Hearty welcome to you. Let's continue with the examples on integrals. We have been asked to find out the integral of root x minus 1 by root x whole square dx. So we know that the given integrand is in the form of a minus b whole square. We know the formula a minus b whole square equal to a square minus 2ab plus b square. So we can write it as root of x whole square plus 1 by root of x whole square minus 2 into root x into 1 by root x whole to the power this whole we have the dx. Now let's simplify this. This is nothing but equal to root x whole square is x plus 1 by root x whole square is 1 by x minus root x cancels. I'll have 2 and I have dx. Now I can separate them and I can write it as x dx plus 1 by x dx minus 2 dx. We know that integral of x is of the form x to the power of n, and the integral is x to the power of n plus 1 by n plus 1. So I can write it as x square by 2 plus integral of 1 by x we know is nothing but equal to log x. So I'll say log of mod x minus 2 into integral of x is x. So I can write it as 2x plus constant c. So this is the integral of the function. What we have done? We have seen a minus b whole square formula. We have applied that. Then we have simplified. We did individual integrals. So let's do one more example. We have to find out the integral of x cube plus 3x plus 4 divided by root x dx. So we'll try to individually divide them. So can I write it as integral of x cube by root x plus 3x by root x plus 4 by root x dx, which is nothing but equal to integral of x cube by root x, that is x to the power of 3 by x to the power of 1 by 2. If we apply a to the power of m by a to the power of n formula, I will get x to the power of 5 by 2 plus 3 into x by root x, that is x by x to the power of 1 by 2, that is x to the power of 1 by 2 plus 4 into x to the power of minus 1 by 2. This whole we have dx on top of it. Now let's try to individual separate them. I'll have integral of x power 5 by 2 dx plus 3 into, I can take the constant out, x to the power of 1 by 2 dx plus, again I can take constant out, I have x to the power of minus 1 by 2 dx. Now the formula we have to apply is integral of x power n is equal to x power n plus 1 by n plus 1 plus c. So let's apply that formula. We have x to the power of 5 by 2, so n equal to 5 by 2. So can I write down x to the power of 5 by 2 plus 1 divided by 5 by 2 plus 1 plus 3 into x to the power of, same logic, 1 by 2 plus 1 divided by 1 by 2 plus 1 plus 4 into x to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. If we simplify, we will get x to the power of 5 by 2 plus 1. If you take LCM, it is 7 by 2, and 1 by 7 by 2 will become 2 by 7. I can write 2 by 7 x to the power of 7 by 2 plus 3 by 2 3 by 3 by 2 will become 3 into 2 by 3, 2. You can simplify that. 2x to the power of 3 by 2 plus 4, and 1 minus 1 by 2 is 1 by 2. 4 by 1 by 2 is 4 into 2, 8. So it will become 8x to the power of 1 by 2. Or I can also say 8 root x plus c. So that's how we can solve that. What we have done, we have separated them, then we have applied the formula. Integral of x to the power of n is x to the power of n plus 1 by n plus 1 plus c. Let's go to the next one. We have to find out the integral of x cube minus x square plus x minus 1 divided by x minus 1 dx. This is what we have to find out. Now we know integral of x power n, other than that we don't know as of our current knowledge. So I have to make sure that the denominator cancels out, so that I get the problem in the form of x to the power of n, terms of x to the power of n. So for that I will try to factor out x minus 1. I see x cube and x square. So can I write x square into x minus 1 plus 1 into x minus 1 divided by x minus 1. From the two terms I can take x minus 1 as common. So that will make it x minus 1 into x square plus 1 divided by x minus 1 dx. I can cancel x minus 1, x minus 1. I'll have integral of x square plus 1 dx, which I can write as integral of x square dx plus integral of 1 dx. Integral of x square, now it's simple now, so I can directly use the formula x cube by 3 plus integral of 1 is x. How it is? Because when I say 1, it is 1 into x to the power of 0. So n is 0 now. If n is 0, it will become x. X power 0 plus 1 by 1, that is x, plus constant c. So it becomes x cube by 3 plus x plus c. Let's do one more. We have to find out the integral of 2x minus 3 cos x plus e power x dx. So let's try to separate them now. Can I write it as integral of 2x dx minus, I can take constant out, integral of cos x dx plus integral of e power x dx. We know 2 I can take out. Integral of x dx is, we know that according to the formula it's x square by 2 minus 3 into integral of cos x is sin x, we know that, plus integral of e power x is e power x plus constant. If I simplify, I can cancel 2 and 2. I'll have x square minus 3 sin x plus e power x plus c. So that's how we can simplify that. How to find out the integral of 2x minus 3 cos x plus e power x? We have separated them, then we have applied the individual formulas. We got the answer. We'll do one more. We have to find out the integral of secant x multiplied with secant x plus tan x. So we don't know any formula as of now to multiply two functions and find out the integral. So I'll try to convert this into one function by multiplication. I'll have secant x into secant x is secant square x plus secant x into tan x is secant x tan x. So next step, we'll try to separate them. We'll have integral of secant square x dx plus integral of secant x tan x dx. We know integral of secant square x, that's equal to tan x. We know that, we have seen it in the last session. Similarly, integral of secant x tan x is secant x plus constant. So the answer is tan x plus secant x plus c. Let's do one more. we have to find out the integral of secant square x by cosecant square x dx. We don't have any formula for division of functions. We, as of now, we are not aware of that, so I'll try to convert this into single function which we know, so that we can apply the formula. Okay, now always we'll try to convert them into sine and cos. So I'll write, can I write secant square x as 1 by cos square x and 1 by cosecant square x as sine square x? I'll have, that's equal to integral of tan square x dx. Now we don't have any integral for tan square x, but we know secant square x. So let's try to convert tan square x as secant square x minus 1, so that we can find out the formula. We know the formula for integral of secant square x. So this becomes integral of secant square x dx minus integral of dx. Now we know that integral of secant square x is tan x minus integral of 1 is x, we have seen in the last session, plus c. So it becomes tan x minus x plus c. We'll do one more example. We have to find out the integral of 2 minus 3 sin x divided by cos square x dx. So let's try to do individual division here. It will become 2 by cos square x minus 3 sin x by cos square x. I have dx on that. That's nothing but equal to, one more step, I can write it as 2 secant square x minus sin by cos is tan and one more cos is left out. So can I write it as 3 secant x tan x? 3 secant x tan x, and on we have to do dx to that. Now let's try to individual them, separate them. I have 2 out. I have integral of secant square x tan x minus 3 I can bring out. Then I'll have integral of secant x tan x dx, which is equal to integral of secant square x is tan x. So I can write down 2 tan x minus integral of secant x tan x is secant x. So I can say 3 secant x plus constant. So the answer will be 2 tan x minus 3 secant x plus c. So these are the some of the examples where we have done simple examples where to find out the integral of a function. So just before summarize, and we will go to methods of integration where we will go through substitution, partial fractions and integration by parts, which is coming in next sessions. We'll try to recap what we learned. Differentiation is knowing the function, finding out its derivative. Integration is knowing the derivative, tracing back to the function. So if you know a function, how to find out the derivative, it's nothing but you know how to find out the integration of the function. Suppose you have to find out different integral of 2x. You have to find out the function whose derivative is 2x. Then that function is nothing but your integral. We know that derivative of 2x square, x square by 2, derivative of x square by 2 is equal to 2x. Therefore I can say integral of 2x is x square by 2. In the last session we have jotted down all the formulas for integrals. So once you are very comfortable with them, you can directly use them in the problems to solve them. So I'll catch you again in the next session where we will learn about methods of integration. As part of that, we'll try to understand method of substitution. Thanks for your time and support. Bye for now.